Hello, I'm Francia Ortiz.
Hello, I'm Carolina. Hello, I'm Victoria.
Hello, I'm Orlando. We're going to solve the given problem, with the information we researched, and that is going to be presented here.
So, a rational function is a function that is a radio of two polynomials. It's called rational because it's divided by each other and like a radio. So, in other words, the rational function is defined by a rational fraction. So both the numerator and the denominator are polynomials, and they need to not be rational numbers.
Okay, so first of all, what is an oblique asymptote? It's a line with a linear function that can be found only when the horizontal asymptote is not present in the graphic. Okay, so the first step for finding an oblique asymptote is to check that the numerator power is superior than the denominator power. And for this reason, 3 is superior than 2. So we're not going to find an horizontal asymptote, but we are going to find an oblique asymptote. What we need to do next is to solve this function so that at the end we can get the form of a linear function.
This is the final result of the function we had, and it has the form of a linear function because we know that y it's equal to x, and this is just the value of a constant. Here is a oblique asymptote that, as we can see, it has this shape of a linear function.
So two applications for rational functions could be, for example, a student goes to school all this time, and then the symptom is the time he stops to go to his house, and then he continues to study. But then there's a gap if he wants to, I don't know, take a break, and then he continues to study. This is an example of it. Another example is, for example, when you're filling a bucket with water, and well, you put it here, it starts filling, it stops, it's already full, then you pour it, and then you put it again, and it starts filling again, and we take out the gap. It continues to fill.
A piecewise function is a function that needs different processes or pieces to obtain the given output. Therefore, piecewise functions are functions in which more than one formula is used to define the output. Each formula has its own domain, and the domain of the function is the union of all of these smaller domains.
So what is an absolute value? All absolute values, they don't have negative numbers. They are only positive or 0. So it represents an absolute number when the bars are at the sides of the number. And other thing is that in the graphic, if it's the constant inside of the absolute value is positive, then it moves to the right. But if it's negative, to the left. And if the value of j is negative, it goes down. But if it's positive, it goes up.
So the power of the numerator is superior than the power of the denominator. So because of this, there's no horizontal asymptote, and when there's no horizontal asymptote present, we are going to find an oblique asymptote.
So there is no gap. Why? When we tried to factorize this, it was impossible to cancel from top. So in conclusion, we don't have a gap.
So in order to find the vertical asymptote, we need to solve this part of the function, which is going to be so because of this result, we are going to have two vertical asymptotes, which are going to be
x-intercepts, we are going to take the upper part of the fraction. And then we're going to analyze these two parts separately. So this would be
So the intersections of j are gonna be 0, 0 because the functions are going to be over here except the one that goes in the middle.
For doing this, we need to use the function and to use this type of division.
Okay, to obtain the oblique asymptote, we're going to divide the numerator and the denominator by doing a long division. So we put already this, we're going to replace this by 0, the ones that are missing. And then while doing the division, that gives us 4 times x, it's going to be x cubic, we cancel it, x squared, 4x. Then we cancel them, and then it goes 4 x squared goes 4x. And then we multiply by 1, that gives us this exact number, but we're going to replace 0 here, and that gives us 4x plus
4. So now we have the result, which is this one with the residual, and here we can see that it's a linear function because it's like y mx plus b.
So to get the points in which the line is going to pass by, we need to substitute the value of x in the function to get the value of j in order to know exactly in which points it's going to pass the line.
So to complete this table, we put some values in x, like minus 3, minus 2.5, 3, and 4. And imagine this doesn't exist. So we're going to calculate this. In order to get these values, we substitute x by, for example, minus 3. We're going to do that, for example. And it gives us this. This answer gives minus 18.5 times 1. And that we're going to put it right here. And we do that with every single one of them.
Now we have everything to do the graphic, and once the graphic is done, we can do the domain and the range.
So in conclusion, we learned a lot because we learned a new type of rational function, and this one is very particular because it has no gap and no horizontal asymptote, and it's very interesting. So thanks.